Hi again, everybody. We're going to start chapter 1 and do the first couple of sections being section 1.1 and 1.3. 1.1 is linear equations that only have one variable. And so remember that a linear equation, linear means that you'll have an x to the first power only, or no x's at all. So things like x plus 2 or 3x minus 7, these are linear expressions. And so to make an equation with one of these, what we'll do is we will put an equal sign and be able to isolate the x from one side or the other. So a linear equation in one variable is any equation that can be written in this form up here at the top, this ax plus b equals c, where a is not 0. If a were 0, then it wouldn't matter if you had an x there or not, because you just have a times 0 times x, which is just 0. And so you have to have a number in front of the x besides 0. And that's what I was talking about on the previous page. You might have like 2x plus 3 equals 7. That would be a linear equation. And so for all real numbers a, b, and c, the equations are equivalent down below, that if you have a c value on both sides, there's a c right here and a c right here, you are able to subtract that c from both sides, and if you were able to get rid of it, you would only have the a and the b left over. And same thing on the multiplication, you have a c that's on both sides, and so if you were to get rid of it by, say, dividing by c on both sides, you could get the a equals the b. And so that's what we'll be doing. We'll be adding and subtracting or multiplying and dividing to get rid of different numbers so we can isolate the x by itself. So in general, it's a four-step process. We want to, first of all, get rid of any fractions that we have. You may not have fractions in every problem, and so if you don't, you skip that step. But if you do have fractions, we multiply every term by the common denominator of the fractions. Once you get rid of those fractions, we simplify the like terms, much like with what we did at the very end of the last video. Simplify the like terms on each side of the equal sign. And in the third step, we isolate the variable. We try to get the x by itself. And so we'll put terms with all the letters on one side of the equal sign, and anything that doesn't have numbers on, or sorry, doesn't have letters on the other side of the equal sign that are just the numbers. And whatever you do to one side of the equation, you must do to the other side. You have to keep it balanced. And then once you do that, sometimes you'll end up with a number in front of the variable. So we'll end up dividing by the number that's in front. And so that's your four-step process that we'll go through. Like I said, a lot of times you won't hit every single one of these steps if it doesn't have fractions, or if there's not a number in front of the variable, we might get to skip one of those steps. So let's jump in and see if we can't solve some problems. So this first one says, solve the equation 2x minus 5 equals 7 plus 6x. First step, there is no fractions, so we skip that part. There's no fractions to worry about. We don't have to do that. Second step is to simplify each side of the equal sign. And so some people like to draw a line right through the equal sign like this. And you can do that if you want to. And you look on either side of the line and say, well, do I have to simplify? Well, the 2x and the minus 5, no. They don't go together. They are not like terms. The 7 and the 6x, again, are not like terms. So I don't even have to do step 2. So we're going to go on to step 3. Step 3 is to get the x's, all the letters to one side and all the numbers to the other. And I can do that by adding and subtracting. So I can subtract the 6x to the left-hand side. And so that would leave me with 2x. Oh, sorry, I didn't subtract it, did I? Oops. 2 minus 6 is negative 4x minus 5 equals 7. And then I would do the same thing with the 5. I would want to add 5 to both sides. That will cancel the 5 and the negative 5 off to give me just negative 4x equals 12. So I'm left with, I'm going to write it over here on the right hand side, negative 4x equals 12. At that point, I would divide, we're on to step 4 now because we got all the x's on the left hand side and only numbers on the right. So step 4 is you got to isolate the x by dividing by whatever number is in front of the x value. And if I do that, the negative 4 cancels, and I'm only left with x equals, and 12 divided by negative 4 is negative 3. You should expect one number for an answer on a linear equation. And so number 2, I'm going to do the same sort of process. I'm going to divide it at the equal sign like I did on the first one. And I look to see, are there any fractions? There are no fractions, so we can skip that step. But the second step is to check to see if I need to simplify any side. The x plus 6 on the right-hand side is perfectly fine. They are not like terms. They do not combine together. On the left-hand side, though, I do need to do some simplifying. For instance, I need to multiply this 2 across on each one of those terms. And I'll end up with 2x minus 10 plus 3x equals x plus 6. And then I have to go a step further because on the left-hand side, I have a 2x and a 3x. These two terms right here combine together to give me 5x. And then the left-hand side is simplified. You cannot combine the 5x and the 10. They are not like terms. And so both sides are simplified. So we go to step 3. And step 3 is to move all the x's to one side and all the numbers to the other. So what I would want to do is I want to subtract the x that's on the right-hand side to the left-hand side. And so if I subtract x from both sides, I'll end up with 4x minus 10 equals 6. And then I would add the 10 to both sides. To cancel the 10s off on the left, and I'll have 4x equals 16. And then I'm again come over here onto the right hand side. So I have 4x equals 16. That's as simplified as I can get it. All the x's are on the left hand side, all the numbers are on the right hand side, except for the 4 in front. So my last step is to isolate the x by dividing by 4 on both sides. And that gives me that x equals 4. So hopefully that's not too bad, kind of making sense. We're going to do several more, so it's okay. Right? How about number 3 up here? We have 4x plus 8 plus x equals 3 minus 10 plus 5x. And so, just like before, notice there is no fraction, so we can skip the fraction part. But we do have to simplify on either side of my equation, on either side of the equal sign. On the left-hand side, there is a 4x and an x that can combine together. On the right-hand side, you have the 3 and the minus 10 that can go together. So if I put those together, the 4x and the x will give me 5x plus 8. On the other side, I'm going to go ahead and pull the 5x out kind of in front before I do 3 minus 10. 3 minus 10 gives me minus 7, or negative 7. Then what I want to do is I try to get all the x's to one side and all the numbers to the other. So to begin with, if I was to subtract the 5x from the left and the right side, something bad kind of happens. Notice that the 5x's cancel on the right, but they also now cancel on the left. All I'm left with is 8 equals negative 7. And hopefully you know that 8 and negative 7 are not the same number. They actually don't equal. It is possible that you have no solution. And it is possible to come up with no solution if all of the x's were to cancel like they did here. And you end up with a false statement. So this is a false statement. Eight and negative 7 are not the same. So that means that this has no real solution. Or you might see it as what we call the empty set. Either one of these might be on the homework for an answer. On number 4, again, no fractions. So we skip the fraction part. If I divide it like I've been doing all the rest of them, the left and the right, again, do have to be simplified. On the left side, what I need to do is I need to multiply this 2 across and make this be 2x plus 4. On the right-hand side, notice I have the 5x and the minus 2x can go together, along with the minus sign. And I could also go with the 3 and the plus 1. They could all go together. And so the 5x and the minus 2x will give me 3x. The plus 3 and the plus 1 gives me plus 4. Now they're simplified on both sides. So what we can do is we move all the x's to one side. So if I subtract the subtract the 3x from both sides, I'll end up with a negative x plus 4 equals 4. Or if I subtract the 4 from both sides to get all the numbers onto the right hand side, I'll get negative x equals 0. Now that is okay. You can definitely have that sort of situation pop up. So if you have negative x equals 0, you technically have a negative 1 sitting in front of your x. So if you divided both sides by negative 1, any number divided into 0, 0 over any number, is going to be 0. And so we'll end up with x just being 0. And 0 is not the same thing as no solution. 0 is an actual number. And so it is perfectly okay to get 0 for an answer. That's different than if you end up with a false statement like we did above. Okay, we haven't tried any with fractions in it, so I'll jump in here and do some fractions on a couple of them as well. Both number 5 and number 6 have fractions. The 5 says x over 5 minus x over 4 equals 1. In this case, the first thing you have to do is get rid of the fractions. So you need a number that both 5 and 4 go into. So you can always just multiply them together. 5 times 4 is 20. Or there might be a smaller number than that. In this case, 20 is as good as you're going to get. So what I would do is I would take each one of these fractions and multiply it by 20. So I'm going to go x over 5, and I'm going to multiply this fraction times 20 minus x over 4, and multiply that fraction times 20. Now the right hand side does not have a fraction, it's just the number 1. But you have to do everything on both sides to keep it balanced. So everything gets multiplied by 20. And then we simplify it. 5 goes into 20 4 times. And 4 goes into 20 5 times. So the 4 that's left over on the first one gets multiplied by the x, that gives you 4x. And the 5 left over multiplied by the x gives you 5x. And the 1 times 20 is 20. Now you're very much like the rest of them. Do you need to simplify either side? And the answer is, well, yeah. The left-hand side, the negative 5x and the 4x could go together to give you negative x. And really, that's all you can do at that point. Then, just like on the last one, to get rid of the negative, I could divide by negative 1 on both sides to give you that x equals negative 20. And that's your answer. I'm going to do the same thing on number 6, get rid of the fractions first. And so, very much like I did up there, I need a number that 4, 2, and 6 all go into. Now, if you multiply them all together, 4 times 2 would be 8, 8 times 6 would be 48. 48 would definitely work. 48 is not the best number that would work, because 4 will go into, say, 24, and 2 will go into 24, and 6 will go into 24. So that's a little bit better. Even better than that, 4 will go into 12, 2 will go into 12, and 6 will go into 12. So 12 would be the least common denominator. But any of those would work. I'm going to use 12 because it's the lowest number that all 3 numbers will go into. So I'm going to take the 3 over 4, and I'm going to multiply that by 12. Again, if you noticed, you could multiply it by 24 or 48. That also works. And you'll also know that you may not have gotten the right common denominator if you try to multiply it and it doesn't divide evenly. And oops, I left the x off on that 5, 6, didn't I? Oops, there it is. And then the 2 doesn't have a fraction on it, but doesn't matter. You have to multiply it by 12 anyway. And so then hopefully we simplify these fractions. The 4 goes into 12 3 times. The 3 that's left over times the 3 on top gives me 9. 2 goes into 12 6 times. 6 times the 1 on top gives me 6. And I left the x off on that first fraction too, didn't I? Sorry about that. I'll just stick it in there right there. There's an x on there that I didn't notice. On the right hand side, we have 6 goes into 12 2 times. The 2 times the 5 on top gives me 10x. And 2 times 12 is 24. At that point, you just check to make sure you can simplify each side. And in fact, it's already as simple as it gets. The left side, they don't combine together. The right side, they don't combine together. And so we can just start moving x's to one side or the other. I can subtract the 10x from both sides. And I'll get negative x plus 6 equals 24. I can then subtract the 6 from both sides to cancel off on the right hand side and get negative x equals 24 minus 6 is 18. So I'll get negative x equals 18. And to get rid of the negative in front, I just divide by negative 1 on both sides. And that gives me that x equals 18. So hopefully that's not too bad. Okay, here's another one with fractions. X plus 3 over 3 plus x minus 3 over 15 equals 2. Again, I got to get rid of the fractions first. So if you look at this one, the 3 and the 15 on the bottom, you could multiply them together. 15 times 3 is 45. So if you wanted to use 45, that will absolutely work. But that's not the easiest one. The easiest one would be 15. 15 goes into 15. 3 goes into 15. And so I'm going to multiply everything by 15. But actually, any multiple of 15 would technically work. So I'm going to write the x plus 3 over 3. And we're going to multiply it times 15. Plus x minus 3 over 15. And I'll multiply that times 15. And even though the 2 doesn't have a fraction, it still gets multiplied times 15. And then we simplify it. 3 goes into 15 5 times. That 5 that's left over will get distributed on each term inside the fraction. So the 5 times the x gives me 5x. The 5 times the 3 gives me 15. On the second fraction, 15 goes into 15 one time. And so technically you're doing 1 times each one of these two terms inside. 1 times x is x. 1 times negative 3 is negative 3. The right-hand side, 2 times 15 is 30. And then we try to simplify each side. The right-hand side is just the number 30, so there's nothing to simplify there. But I have a 5x and an x, so those two terms will give me 6x. And 15 minus 3 is 12. That's as simple as it gets. They're not like terms at that point. So what I'm going to do is start rearranging from left to right of getting the x's together and the numbers together. All of the x's are already together, so I don't have to do anything with that. But I do need to move the 12 to the right-hand side. And that'll leave me with 6x equals 18. And then to get the x by itself, I would divide both sides by 6. And so x equals 3. By the way, on any and all of these problems, you could take the x value that you ended with down here, plug it back in. If you took that answer and plugged it into your original equation, it should come out to be 2. If you did 3 plus 3 over 3 plus 3 minus 3 over 15, that should come out to be 2. And it does, if you wanted to check it. So the next section we're going to look at is 1.3. That is applications of linear equations. So your applications are basically just word problems. We're going to read through a word problem, assign an unknown variable, an unknown value, a certain variable. We have to write out the equation, which is usually, I have found in the past, the thing that most people struggle with is actually writing the equation out. If they write it out correctly, most of the time it can be solved fairly easily using the same techniques we just did on the previous slides. And then usually we don't leave it as x equals a number, but we actually say that that number represents something, and that's stating the answer. So we're going to do a few different types of problems here. So the first one is you have the length of a rectangle is 1 more than twice the width. The perimeter of the rectangle is 110 centimeters. Find the length and the width of the rectangle. And so occasionally some people like to draw out a picture. So if you'd like to draw a picture, you can. So there's a really bad rectangle right there. The thing you want to look for is your unknown variable should be whatever is at the end of a phrase. Like for instance, the length of a rectangle is one more than twice the width. Your width is at the end of the phrase. So I am going to assign the width to be my x. And so on my rectangle over here, my length will be, oh, sorry, not length. I said width, and then I wrote length. My width will be x. The rest of that sentence, the length of the rectangle is one more than twice the width. The rest of that is the formula for the length. So the length is one more than twice the width. So the way we read this, twice the width means that you do 2 times. So we'll have 2 times x. The word more means you add, and you have 1 more centimeter than that. So you have 1 plus 2x, or 2x plus 1. If it was 1 less than twice the width, it would be 2x minus 1. So just be careful on the minus ones like that. Then it says you have the perimeter of a rectangle is 110 centimeters. Now, as far as that goes, you have to remember from a geometry class or some previous class what the perimeter formula is. The perimeter of any rectangle is twice the length plus twice the width. I know that it's 110 centimeters, so I can just say that. It's 2 times the length plus 2 times the width has to be 110. But I have formulas for the length and the width. So I have 2 times the length, which is 2x plus 1, plus 2 times the width is just x, equals 110. And now that is set up correctly, and we would solve for the x just like what we were doing previously. Just like before, I'm just going to cut it down at the equal sign. Simplify the left-hand side. It needs to be simplified by multiplying the 2 across. And so I'll have 4x plus 2 plus 2x equals 110. Then I could stick the 2x and the 4x together, and 2 and 4 give me 6, so I'll have a 6x plus 2. Then I can subtract the 2 from both sides. And get 6x equals 108. And then that takes care of everything except for isolating the x by itself. And we can do that just by doing 108 divided by 6. So if I was to divide, oops, wrong color, 6 on each one of them, I would get that x equals 18. Now, 18 is not your answer. 18 is one of your answers. So it asks you to find the length and the width. So what you'll see on the homework and such is you'll see a box, and it'll say width equals, and it'll put a box there, so many centimeters. And it'll say length with a box, so many centimeters. You have to know which numbers to put in that box. So the x, since x is the width, then the 18 goes in the width box. So it's 18 centimeters wide. The length, you have to take this 18, and it's got to go into this little formula right here, and say that 2 times 18 plus 1 is what? 36 plus 1, or 37. It is 37 centimeters wide. If you mix the numbers up, they will not be correct. You can't say that it's 37 in the first blank and 18 in the second blank. even if your numbers are right, you're not saying the correct thing. You're not saying the length and the width are the right values. So be careful typing it in and make sure that they're in the right blanks. Okay, let's talk about a little money for a moment. Mark has $40,000 and he wants to take that $40,000 and invest it. He's going to put some of the money in an account that will pay 4% of the interest, and he'll put the rest of the money in an account paying 6% interest. His accountant tells him that the total annual income from these investments will be $2,040. And so how much should he invest at each rate? So if he wants it to be $2,040, how much should he put at 6% and how much should he put at 4%? In this case, the end of the phrase one, it doesn't matter which end of the phrase you use. Notice he will put some of the money in an account at 4%, and then he'll put some of the money in an account at 6%. So it doesn't matter if you let your x be the 4% right here, or if you let the x be the 6%. It actually does not matter. You could do either one. I'm going to go with the 4%. So I'm going to let this one be x. So I'm going to say that is x at 4%. Now, since it says remainder, the rest of the money got put in at 6%. The remainder is whatever was let for x on the 4%, you have to take that off of the 40,000 that was started. So I would do the total, the 40,000 minus x, that would be at 6%. And so what I do is I multiply these two things together. I do 4% times x plus 6% times, oh, I left a zero off, didn't I? It's 40,000, not 4,000. 40,000 minus x. That has to equal 2040. Has to equal ever how much money you made. And so here we don't have fractions, but we'll end up with decimals. 4% or 6% is a decimal. It is 0.04 or 0.06. What I usually do on these is get rid of the percent signs because the decimals, some people don't like the decimals and such. So what I do is I multiply this entire thing. Everything in the problem gets multiplied by 100. And that will get rid of your percent signs. So you'll end up with 4x plus 6 times 40,000 minus x equals 2040, but with two additional zeros because you multiply it by 100. Notice you do not multiply the 40,000 by 100. Every once in a while I'll have someone ask me that question. You don't do that. The 100 only wipes out the percent signs. And now we have a problem, much like on the other ones. We could simplify left to right and that sort of thing. The right-hand side is just a number, so we don't do anything with it. But the left-hand side, I do need to multiply this 6 across. So I'll get 4x plus 6 times 40,000. 6 times 4 is 24, so you'll end up with 240,000. Oops, minus 6x. I left the 6 off. Then I can simplify it a little bit further because the 4x and the minus 6x would give me a negative 2x with 240,000. Then I can move all the x's to one side, which they already are, but I could move all the numbers to the other side as well. So I'll subtract off the 240,000 from both sides. And I'll get that negative 2x is, might have to go to the calculator for this, 204000 minus 240000 gives me negative $36,000. And then, because there's a negative 2 in front of the x, I could divide by negative 2 on both sides. And I get that x equals 18,000. Again, that's not your answer. They want to know how much should you invest at each rate. So just like on the last problem with the length and the width, you'll get something that looks like a box at 4% and a box at 6%. And you got to make sure you put the right amount of money in each box. Well, the x is the amount at 4%. And so in the box goes 18,000 at 4%. To get the amount at 6%, you have to do 40,000 minus x, which is the 18. Oops, one too many zeros. So 40,000 minus 18,000 gives you 22,000. So you need 22,000 at 6% and 18,000 at 4% to give you $2,040 in interest. Wasn't that fun? I can literally see your head shaking right now. Okay, the third type of problem we're going to look at in this section is mixtures. So you can mix chemicals, acids, bases. You can mix whatever you want to mix. You can mix alcohol if you want to. A chemist must mix 8 liters of a 40% solution with some 70% solution to get a 50% solution. How much 70% solution should be used? Now, you won't see this on like the help me solve this or view examples or anything that are online on the website, but I do this with little tubs. So I draw a little tub, and I add another amount in a different tub, and that's equal to some other amount. And on the front of the tubs, I put my percentages. There is a 40% solution, there is a 70% solution, and there is a 50% solution. You should have 3 percentages in the problem somewhere. And it doesn't matter which ones you put where except for the last one. This 50%, notice that 50% is in between 40 and 70. And so since it's between 40 and 70, then I have to put the 50%. It has to go on this tub. The number between the other two numbers is the tub on the last tub. Now they tell you I have an 8 liters of a 40%. So I put the 8 on top. But I don't know what the 70% is. So I'm going to let that be my x, because it's some amount of that 70% solution. So I have an 8 on top and an x on top. So if you add straight across the top, I would have on the last one would be x plus 8. And what you do is you multiply the tubs together. I do 40% times 8 plus 70% times x equals 50% times x plus 8. Now, much like the money problem, you can get rid of all the percentages by multiplying by 100. This is very much like what you would have seen if you watched the movie The Incredibles. That's a great movie, by the way, if you haven't watched it. But in The Incredibles, you notice somebody says that if everyone is super, then nobody is. Well, same thing applies here. If everyone has a percent sign on it, then no one needs a percent sign. So if you multiply everything by 100, you'll just end up with 40 times 8, 70 times x, and, oops, that's supposed to be an equal sign, and 50 times x plus 8. And then we have it set up correctly. If I solve this, the left-hand side does have to be simplified a little bit. The 40 times 8 is 320, so I'll go ahead and make that be 320. The right-hand side, I will want to multiply the 50 across, and I'll get 50x, and 8 times 5 is 40, so that would be 400. And then I need to move all the x's to one side and the numbers to the other. So I would subtract the 50 from both sides, 50x, and get 320 plus 20x equals 400. Subtract the 320 from both sides, and get 20x equals 80. And then I can get the x by itself just by dividing by the 20 on both sides. If I divide by 20 on both sides, I'll get 80 divided by 20, which gives me x equals 4 liters. And in this case, that is the answer. There's nothing else to plug into it because they're only asking you what the amount would be of the 70%. And that amount, from back up here, is x. So I don't even have to plug it into anything. If they ask you the amount that you have total on the 50%, then you would have to add the 4 plus 8. You actually end up with 12 liters total at a 50% solution. So I'm going to do one more of those with pure something. So we have how many liters of pure isooctane fuel should be mixed with 200 liters of a 94% isooctane to get a mixture that's 98% isooctane. And so I want to do the same thing. I'm going to do the same 3 little tubs. So I have a little tub, and a little tub. Tub, tub, and tub. So on the front of those tubs, I should have 3 percentages. In the problem, it looks like I have a 94 and a 98, but I actually have 3 different percentages because pure is a percentage as well. So pure means you have 100%. So I have 100%, a 94%, and 98 is between 94 and 100, so it goes on the end. I don't know how many liters of the 100% I should mix, so the 100% would be the x. But I know there are 200 liters of the 94. And if you add straight across the top, I would have x plus 200 on the third little tub. I then multiply the tubs together, 100% times the x plus 94% times the 200. That'll be equal to 98% times x plus 200. And just like on the last one, if they all have percentages, any of them need percentages, but that is because we can multiply the whole thing by 100 to get rid of the percents. And so I'm left with 100x plus 94 times 200. That is equal to 98 times x plus 200. And I do the same sort of thing I've been doing on all of these problems. I want to simplify each side, which I do need to do a little bit of simplifying. I have the 100x, but I have to do 94 times 200. That gives me 18,800. On the right-hand side, I need to multiply the 98 across. And so I'll end up with 98x and then I'll end up with 98 times 200, which is 19,600. They are as simplified as they can be on either side. And so what I'll do at this point now is subtract the 98x to the left-hand side to combine my x's together. That just leaves me with 2x left over. And then I'll want to subtract off the 18,800 to get it to the right-hand side. And get that 2x is 800. And then all I got to do is get the x by itself by dividing by 2 on both sides. So 800 divided by 2 gives me 400. So x would be 400 liters. And all I'm looking for is the x value here, just like on the last one. It asked me how many liters of the 100%, which would be just what x is. And so if you mix 400 liters with 100 of 100% mixed with 200 liters of a 94, you'll get 600 liters at 98% isooctane. And so that's the end of this video. We are done with 1.1 and 1.3 here. And so we're going to continue on with chapter 1 and do a few more sections in the next video.